Hi everybody, today I'm going to show you how to download and install Visual Studio in order to compile C++ programs. To do this, you're going to want to log into My ASU, then go to My Apps, and click on DreamSpark, or download from third party over here. What DreamSpark is a portal to downloading all of the Microsoft products that ASU has partnered with to get for free for you guys. So here there's right on the front page is Microsoft Visual Studio 2013. You could also get Visual Studio 2012 and just download whatever the latest version is. The Ultimate is the biggest one, but Professional will be more than enough to do the work that we're going to be doing. So once you go and download this, add it to the cart, go through the whole process. Down here at the very bottom is when you add it to the cart, it gives you the option to check out. Just go ahead and check out straight off the bat. So we can go and do that here and go ahead and check out, and that'll allow you to download it and go through the whole process. Once that's downloaded and installed, it's going to take a while, so get ready for that. Once that's downloaded and installed, though, you can start the program just by going to Visual Studio 2012. So I use Visual Studio 2012, which I have open already. So this is the first page you're going to see when you log in. And what we want to do is start a new project. And we're going to be using Visual C++. You want to pick templates, Visual C++, and you want a Win32 console application. If you don't see that here, go to Win32, and we want to pick the console application. You want to give it a name. So this is going to be my Hello World. And just go through the next. I always turn off pre-compiled headers and security development lifecycle checks. We don't really need that stuff. And just hit finish. And this has created for us a little template of a simple and included standard AFX, it doesn't really matter, which is Microsoft thing, and a little simple frame for our first program. Now Microsoft likes this tmain stuff. I don't. I just like my normal good old char star. You don't really have to change it, it doesn't really matter. To do our Hello World program, I want to do include iostream using namespace standard, and just do cout Hello World and del. And since this is going to, when we execute this, it's just going to run through this, and as soon as it returns, the window is going to disappear. I put a system pause at the very end, right? So that's our simple little program. Then all we do is say start the local Windows debugger. I always say do not show this again and hit yes. And there it ran. So what it did here is it started the program, that's what this did. It did Hello World, and then the system pause puts the press any key to continue option in there. So I just press any key and it goes away. So next we're going to I'm going to write a little program that is similar to the homework problem. So let's look at that. So now I've written a simple little program that just kind of loops over and does some math. All the point of this is to take up some time. So all it does is for 10 million iterations, add this number to a accumulating counter and output the value. So when we run it, we should see some really large number. And the reason why this is negative is because it overflowed. It's a long value here, and we did 10 million of those, which caused it to overflow quite a bit, which is okay, right? But one of the points of this is to measure the amount of time that it took to execute this. Now in the homework example, we used datetime.now.ticks. We don't have that in C++, so instead we use the time library, time.h. And if you Google this, we go to here, and we do C++ time.h. We got a C++ reference, and we've got a bunch of functions that this includes. The one we're concerned about is clock. And if you look here, the way the clock works is it returns an integer that is the amount of time that has elapsed since the program started in ticks, right, which is system ticks. Now, to figure out how long a program executes, we call clock once and save its value away, so that's the start time, and then we do a bunch of stuff, we do a bunch of math or something like that, and then we call clock again and subtract this new larger value, subtract our start value from this new larger value, and that gives us the elapsed time. So let's add that to our program. We want a long start one clock, right? So that's our start time. We do a bunch of math, and then our long elapsed is equal to clock, which is the time now after the math, minus start one, right? And I'm going to add a cout for how long that was. Elapsed. And del. Right? So now let's execute this. Bam. Right? So I've got the sum again now, and now I've got the time elapsed. Now this didn't take 27 seconds, obviously. These are ticks. This is a system tick. And if we wanted the real time, we just divide elapsed by a macro that's defined by the system called clocks per sec, which is this guy right here, right? And this, we have to make it a float, right? And now if we try this again, I have to make sure to exit this. We try it again, and it gives us 0.027. So we know that the number of ticks per second is about 1,000. So it took 27 thousandths of a second to execute that program. And you can use this same set of calls on Unix. This is a cross-platform. It's part of the C++ standard library. So go ahead and use that, and that'll get you through your homework. Okay? Let me know if you have any questions. Thanks.